All right, so let's see if we can, let's go over 6.3 number 31. So 6.331 says, use cylindrical shells to find the volume of the cone generated when the triangle with vertices 0, 0, 0, R, and H0, where R and H are positive, is revolved around the x-axis. Okay, so first of all, drawing a picture of this scenario, there's 0, 0. If we call this thing H, then this would be H0. And if we call this R, then that would be R0. And there's the, that was a bad, that's supposed to be a straight line, but there's the picture that we get, right? So it's this triangle. And we're going to revolve this thing around the x-axis. And so you can see when you do that, obviously you're going to get a cone. Now, if you know your geometry really well, then you know that the volume of a cone is 1/3 the volume of the corresponding cylinder. So that the volume of the cone we should get here is pi r squared h over 3. So let's see if we can get there using cylindrical shells. So the idea with the cylindrical shells method is that you're going to take a cross section parallel to your axis of rotation. So in this case, you know, if I take a cross section like that, and if I call this thing y, then this we can call x, but I need an expression of x in terms of y, so I'm going to call it x of y. Now, how do I get that expression? Well, this line segment is just a straight line, and it has y-intercept r and slope negative r over h, right? Because you go down r over h. So that line segment is the line segment y equals negative r over h times x plus r. Then you want to solve that thing for x, right? So we divide or multiply through by h. You can move over the RH. And then divide through by negative r. I'm going to switch the order of subtraction to take care of that negative sign, but I'm going to get x equals, here when I divide by negative r, the r's just cancel. I get h minus yh over r. Okay, so there's my expression for x, right? So now, the question is, so the idea is that if I take this cross section, I'm going to get a cylinder. I'm going to get this like hollow cylinder, and I want to know what is the surface area of that cylinder. Because if I can do that, if I can find the surface area of that cylinder, then I can find the surface area of this cylinder and this one, and I can add them all up between 0 and r, and that should give me the volume of the cone, right? So how would I find the area of the cylinder? Well, if you imagine unfurling it, you're gonna get like a rectangle, okay? And the height of this rectangle is going to be the same as this length right here, which we called x, right? The length of the cylinder is going to be the circumference of, or the length of the rectangle is going to be the circumference of the cylinder, which is 2 pi r, right? 2 times pi times r. Well, what's r? R would be y, right? So it's 2 pi times y. Okay, so the area is going to be this times 2 pi y. So x, in other words, h minus yh over r. So I'm going to say equals h minus yh over r. So it's going to be h minus yh over r times 2 pi y. That's the surface area. So A is, maybe I'll do it like this, 2 pi y times h minus yh over r. Okay, so that's the surface area of each cylinder at any point y between 0 and r. This is going to be the surface area of the resulting cylinder. So then the volume is just going to be the sum of all of those, right? It's going to be the integral from 0 to r of 2 pi y times h minus yh over r dy. Okay, so let's clean this up a little. I'll take the 2 pi out and distribute the y in. So hy minus hy squared over r. dy. Okay, and now we integrate. We're going to have 2 pi times hy squared over 2 minus hy cubed over 3r. Remember, h and r are just constants. They're just unknown constants, right? So, anyway, that's what you would get. We evaluate that from 0 to r. So if we plug in r, we get hr squared over 2 minus hr cubed over 3r. And if we plug in 0 for y, then we get 0 minus 0. Okay. So that's 2 pi times, now here the r's cancel, so you have hr squared over 2 minus hr squared over 3. So that would be 3r squared over 6 minus 2r squared over 6. That's just r squared h over 6. Okay. And then you can cancel the 2, and you'll get, and put the pi in the numerator, you get pi r squared h over 3 as desired. Okay, so that's that one. Hopefully that helps.